All right, I think it's 2:30 p.m. So let's get started. So, hello everyone, and thanks for taking your time and joining us today for this session. So today we're here to talk about this interesting topic on how system integrators can leverage on OPC PubSub for cloud integration. I'm Nitin. I'll be your host and moderator for today. And personally, it's an exciting session because we have, for the first time, experts from two worlds within our industrial automation space, as we call it, where the OT side of the story and the IT side of the story comes together to sort of solve business problems for the customers, right? So I'll probably introduce you to our experts a little and give you a brief on what they sort of have to say here, particularly. So, briefly, I think Praveen, you would have probably been familiar with his face over our sessions, and he's our OPC expert, and we'll be sort of addressing points from an OT standpoint. He's currently joining in from Pune, and the other expert with me is Adarsh, who is our cloud expert. And Adarsh, it's his first session today, so we're sort of excited to listen to the IT and the cloud side of the story as well. And Adarsh works very closely with a lot of our customers who are independent software vendors as well as OEMs on enabling their industrial cloud journey. So, a couple of logistics. If you be during the session, if you have any questions, please feel to free to sort of drop them in the comments, and we'll address them as we go, or we can take that up in the end of the session. So, so let's get started. Like, I think the first question I have is on the cloud front. So, let's probably hear from Adesh, where I think there's been wide scale research on how the industrial crowd is moving towards uh, in this whole industry, IoT and the Industry 4.0 journey, right? And we're also seeing particularly a higher rate of adoption for Azure over the last few years, and would like to sort of understand what is some of the factors that are influencing these decisions from customers, and probably Azure also a little more in specific. Yeah, I think over to you, Adish.
Okay, thank you, Nitin. Thanks for this opportunity. Okay, coming to that point, so we all know that the Azure gaining popularity and closing the market gap with Amazon. I mean AWS. Even though we know that AWS is leading, but Azure is closing the gap very quickly, and it is currently holding a market share of close to 21% in the industrial automation arena. So with all that, why it is gaining popularity is the services that Azure is providing, and also the flexibility of adopting these services. So Azure is as flexible as pay as you minute. They charge as per the minutes. This is one point. And another point is the legacy applications which is running in the industrial arena. So most of these are very tightly coupled with the Microsoft
Mhm.
services, and with that, Azure is all the Azure cloud services are very closely integrated and easily integrated with this Microsoft legacy applications. That is one of the major reasons why this Azure is gaining popularity of late. Yeah.
Sure, that's interesting. Thanks, Adish. So probably just to add to that, right? So Praveen and I also work very closely on some of our OPC products, and we've sort of been working closely with Azure on making our OPC products available as data connectors and products in Azure as part of the IoT hub. And things have been great from the outset, and the sort of seamless experience that customers get, I think we've seen it firsthand. And yeah, I think just going off what you said, I think this is just the inflection point. So we'll probably see a lot more sort of use cases coming up and the whole ecosystem developing along the way, right? So yeah, thanks for that. So what we'll probably do now is we'll probably take an interesting take from Journey here, right? In terms of without sort of going into too much of like nitty gritties of the technology components involved in how OPC, OT, IT, and all of these things come into the picture. Uh, we'd sort of like to bring up a business case, and this is a business case that's also a little personal towards Praveen as well as Adarsh, where they collaboratively work together on solving a business problem for OT/IT integration. So the highlight for this session, in terms of the use case, was that this is specifically for one of the leading Indian steel conglomerate, right? And where there was a brownfield setup, and the customer came to us with a problem, and how you guys sort of went about sort of solving this niche sort of thing with the solutions that you guys have. Um, Probably I'll hear from Praveen. Praveen, I think if you can sort of shed some light into what the problems the customers encountered and how this came about, so that'll be great.
Sure. So, thanks, Nitin. And good afternoon, everyone. Thanks for being on the show. So, Nitin, as you said, we are actually taking a use case from a major steel player, but let me emphasize the fact that this is a problem that we are seeing everywhere. So, I have been to many customer site, and the problems are very similar. Okay, so we went to this particular site where they had this old setup. They already have existing setup, but the problem is it's a plethora of devices. There are a lot of devices which has been configured over a period of time in different phases for different teams. And because they have been configured over a different period of time, they are running a different protocols, they are from a different vendors, they are set up in a different way. Okay, now the client has a requirement or has a need to go for a complete digitization. Okay, now what that means is basically they want to have this digital factory concept implemented. Okay, where a great deal of automation can be achieved. And how do you achieve that? You achieve that by having a digital twin of almost every asset in the digital factory. When you have a
Got it.
digital twin of every asset, you can see everything almost live, and you can change things, look at the parameters. But to now make both digital factory and digital twin functional, you need data. You need a lot of data, right? And from where
Yep.
you get the data? You get the data from a data lake. So their requirement was take all this setup which is there already existing, okay, whatever way they are running, get all this data, get to a cloud, okay, get to a data lake, and build a factory, digital factory around it. Okay. Now, now the problem is that all these are high efficient plants. All this plant that we are discussing are producing high amount of product, and you can't just take down the plant for doing a digitalization.
Yep.
You have to do all these things at the same time. The plant has to be functional. The downtime has to be minimal. So what this means that you have to do a great amount of planning, okay, great amount of assessment even before you get there. Okay, so when we went there, our first step was to get the data, to get the data about inventory of the devices, from which version they are coming, from which vendor they are coming, what protocols they are supporting, okay, and build the inventory and show it to client, oh, this is what you have. Are you on the same page? And once you
Yep.
get that, once you got that, then the next step was how do you go about moving the data upwards? Okay.
Correct.
Now the next step, what we did is once we had this inventory listed and we got customer together and we were on the same page, we said, hey man, what we'll do is we'll try to bring one protocol on all the levels.
Got it.
Because if you want to move data upwards, at the same time, you want to have a common protocol so that the data does not lose sense and it is easy to bring it. Now the only
Yep.
protocol which can do this is OPC UA. Because of the way OPC UA is implemented, okay, it can work on every level, right?
Got
So
it.
the first step was, without disturbing the existing setup, by putting adapters or converters on top of it, we started converting whatever data was available into a OPC UA format. Now this is OPC UA TCP IP. Okay,
Got it.
we are talking about OPC UA TCP IP here, so that data starts going upwards. Okay, so now there's OPC UA server. we'll try to put a wrapper or a OPC UA converter. If it is a device with the field protocols, we'll try to use an OPC UA server which suppose that field protocol and get the data. Okay. Now, in our current case, the case that we are discussing, they had a lot of OPC classic servers. What I mean was, we were using OPC Windows server, the classic servers. So, with the help of converters, okay, we were able to get the data.
Yeah.
Okay. So, with some customization and some products at the correct places, we started moving data upwards. Now, that's the first part of the story. The second was the cybersecurity. See, till now, all these products were OPC classic products, and they were passing through firewalls. And when the classic product, which means COM-DECOM, has to pass through a firewall, okay, you have to open a lot of ports. Until that time, it was okay because that setup was not connected to a cloud. It was running as a standalone setup, right? But now, once cloud comes in, okay, that risk also of a cloud comes in because now you have internet in place, right?
Yeah,
and you cannot have so many open ports and all that cyber security not implemented, with the cloud coming in. So now we have also had to plug in that firewall, okay, and move up with the firewall, okay, and then get the data to a data hub.
Got it.
So
I think so I think if I sort of understood correctly and summarize what you were trying to say, essentially the sort of business leaders in the organization wanted to sort of start their industry 4.0 journey, and before they sort of go about implementing some of these high level applications like your digital logbook, operation management apps, asset management apps, and all these complex analytics that you would run, the underlying thing is first you need the data to be present in a harmonized way. So that's where that had to be addressed first, right? So I think thanks for that, Praveen. So I think just leading from there, right, like for possibly for the benefit of our audience and for me to also understand what was the existing sort of setup there in the facility, and what did you have to sort of deal with, and how did you sort of going about proposing a suitable solution for them?
So as I was okay, so let me use this architecture, right? So I just talked about it a little bit. If you look at the architecture on the slide, right, these guys had a lot of devices, okay? These devices were having classic servers as well as they had these firewalls, okay? Now on the classic server, we had to first have, and so the first thing we decided was we are going to use OPC with TCP/IP below, okay? And once the data comes to the data gateway or the top level, we'll use OPC with PubSub, okay? Right. Now let me just emphasize on a uOPC PubSub before I go ahead. Now why we are using a uOPC PubSub there, okay? And this is one of our product, this is OPC PubSub, our flagship product. Now why PubSub? PubSub is the only protocol, OPC, I mean when I say PubSub, I mean OPC PubSub is the only protocol today which can take this data and bring it to cloud. And how is bringing to a cloud? Because this protocol works on top of messaging architectures like AMQP or MQTT. Okay. So what we did is on the devices where you already had the classic EC servers, we put it UA converters. We put, in this case, if you look at the specific case, we started using wrappers at the below level. We added wrappers which converted the data from the classic to the UA format, but this is UA TCP IP. Okay. Not the, okay. And also at some places we started using a tunneler to plug the firewall gaps. But this also we are using OPC UA tunneler. That is another topic that we have a video on that. But basically tunneler is plugging the gaps. Now with all this thing, what happened is in some time we started getting data from all L1, L2, L3 level to the OT layer in OPC UA TCP IP format. Okay. Got it. Now, once the data comes in OPC UA TCP IP format, what PubSub started doing is it started getting this data and started converting the TCP IP data to a UA PubSub data. Okay. And if I have to, if our viewers understand this, and they are familiar with Azure Cloud, they know OPC UA Publisher. Azure Cloud has a OPC UA Publisher module. This is very similar to what we are doing here. We are taking legacy devices, converting to OPC UA and converting to a PubSub. But here we can do a lot more things. We have store and forward and other mechanism, but just to bring a context. Once that happens, the next point was take a data from OPC PubSub and start putting to a data ingestion point of the cloud, of the IoT hub. Okay, so Azure IoT hub at the starting point gives you multiple ways to get the data. Okay, it can be a service bus, it can be a queue. Okay, our job was to get the data from the PubSub bridge and on the north side connect to this MQTT queue. Okay, and then the data becomes available to the Azure cloud. Okay,
Got it.
so that's what we did in the phase one, getting other data from below OT layer in the OPC or TCP/IP format, put it at the data bus, the data hub. Okay, where the cursor is on the data bridge, convert the data from TCP/IP to the PubSub format and push it onto the broker. Okay,
Got it. Okay, I think if sort of just going by like what the thing says, right? Phase one, OT data management, where now you have the OT data harmonized and available as a sort of like a single point protocol access. Now, sort of going from there, I think that's where Adarsh comes in, right? Like where how do you sort of ingest this data and what goes into the whole other side of the story and what were the typical building blocks to achieve sort of cloud integration. If you just can sort of explain and throw some light on that, that'd be great.
Sure. Thanks. Thanks, Praveen, for bringing those points. Okay, so now, as Praveen mentioned, once this data is available for consumption to the cloud, so we need, Azure offers you a lot of services, and it's always depends on the type of use cases that you are solving here. I will go through those services, what type of use case that we can solve and all. So now the main point here is the Azure IoT Hub, which gives you a flexibility in terms of connecting to IoT devices and gather the data to and fro, and you can even exchange the data between the devices and to the cloud. So once I have this unstructured data into my Azure IoT Hub, so the first thing that we have to do is what problems we are trying to solve or what kind of data we need to visualize. So based on that, I need to massage this data. So to do that, we have various services. There is no hard and fast rule that everything which is being displayed on the screen should be used, but it can be a combination of that. Say, for example, I can even go with Azure IoT Hub and directly to the data factory and massage my data and start consuming it. Or if I want, for some use cases, I would like to store this raw data somewhere, I would go with Azure Data Lake, where I would store this raw data and then from there consume this data and using a data factory or the stream analytics to massage this data and get a meaningful data out of it. Once this data is there, so then again now I can use various services where I can store this data as probably as an history. You need to have a data to go back in the history and make some decisions, right? So that's where all these data sources comes into picture, like your Cosmos DB or be it Azure SQL or data catalog or whatever it is. So it's all so the architecture what we are trying to present here is a generic one, where based on the use cases you can pick and choose the Azure services that you would like, that you would fit into that, and then bring out the entire data ingestion pipeline to the visualization. So here we can use this data which is came from the OT layer, consume this data using our Azure IoT Hub or the Event Hub, push this data, massage this data according to your use cases or the needs using your data factories, and use your stream analytics to bring out some of the analytics data, and then pass it on to your storages, can be a database, SQL or NoSQL. And post that, that's where the interesting things comes in. Like, once you have this structured and meaningful data, now you have to visualize this data. So the data sitting in database is of no use for anybody. So now somebody has to visualize this. So that's when this features like Azure Power BI comes into picture, where you can directly inject those data into the Azure Power BI and bring out a meaningful visualization, which can definitely give an edge for business guys or the people who can make decision and take decisions out of it. So one more high points that I would like to highlight is there is no hard and fast rule, as I mentioned at the start, that you will have to use these services. Say, for example, you don't have to use Power BI all the time. Say, for example, you can build your custom applications, custom web applications, or custom visualization applications. You can use your app services to host this kind of applications. The data is already available to you in a meaningful way in your database. Create your own sort of applications, use your own chart libraries or any kind of libraries, and host those applications in the Azure service, and then visualize it. So this once you have that data, right? So the visualization, once it brings up, then it starts giving you a lot of meaningful data where they can make very strategic decisions about how their devices are performing, as you mentioned about asset management, health monitoring, various use cases. All those things comes into picture, and it's very handy once you have this data visualized.
Great. I think thanks for sort of bringing all those points in, and hopefully it sort of gave our audience into what the typical building block is and what sort of journey this whole thing comes about before you sort of visualize the data from Azure, right? And so probably I have another question just leading from this, Adarsh. So in terms of uh, once you mentioned about the whole data being sort of available, and then you sort of running whatever you want using Power BI the in this case particularly, right? Like, was there any sort of inputs from the customer as to what they wanted to sort of derive from the data in the OT side, and like what was the ultimate sort of objective to sort of derive any specific apps or something? I don't know, along those lines.
Basically, to answer to your point, it's not that they are looking for any apps or anything at the end result. So they basically want this data to be, see, the data that we get from the hotelier, it is not structured, and directly consuming that data might not give any meaningful information to end users or anybody who consumes that data. So the main aim is how the problems that we solve to them, to our various customers, is how do we massage this data which we have got it. I mean, the data comes in at a very high rate. So the ingestion rate can be high, and that's where all this kind of services comes into handy. Say, for example, Azure Data Lake Storage, it is capable of handling any type or any size of data and at any ingestion rate. So now then we use probably the data factory, which is an ETL, cloud ETL service, where I can transform this data and massage this data according to the business needs. I would say that you give up any business use case. Okay, I would like to see this data in this time series or whatever. We can massage the data accordingly using the ETL tools like Data Factory, and then bring it into the visualization tools or visualization service.
Got it. Okay, I think Praveen, if you would sort of want to add some light into this, right, in terms of like how Adarsh mentioned, the primary objective of this whole exercise is to make sure the structured sort of data is available to do the next thing, right? Particularly sort of narrowing down and putting the uOPC PubSub bridge in the center, right? And we've again previously also spoken about a lot of the use cases it solves. Specifically, if you can sort of summarize what it sort of benefited for the customer, and then we sort of probably go from there.
See, so before I get into that, just one, I want to explain one thing, or add more explanation. I referred a word digital factory, and Adarsh is also referring a word digital factory, right, or data factory here. Okay, these are two different terms. Okay, just to be very clear, data factory or digital factory, which is in the cloud, is a component. The digital factory I was referring was a concept of industrial IoT 4.0, where you bring a lot of automation, and with the automation and good data, you can do a lot of predictive maintenance, where they start taking their own decisions based on algorithms. Okay, so just to be very clear, now, so one thing that I wanted to add was, so when we talk to a customer, okay, we try to tell the customer to tell us what is their problem, okay, and in fact we encourage them to tell us the problem and what they're expecting and not the solution. So we don't really get them what component they want to use and all that. Okay, so we try to stick to that. Now, just to summarize everything, what we try to do here is that based as the see, we are talking about a huge project here. Okay, this project was not supposed to happen in 10 days or maybe in a month. This was supposed to be a year project.
Yeah.
So there, this was going to happen in phases. As we as a OT team start bringing more and more data to the PubSub bridge, okay, and PubSub start putting data to the ingestion points, okay, the IT team or the cloud team of Adarsh will start adding these layers.
Yeah.
Okay, so the client expectation was in the first place, if he gets all the data to a cloud, he's happy. If he can get some of the reports, he's happy. In second phase or in the next iteration, I would have OTT would have ideally preferred, to bring more context to a data by using some information model if possible, talking to the end vendors, getting some information models. For that, we require native vendor support because that cannot be done just by a wrapper.
Yeah.
Okay, maybe write a new server, maybe ask the vendor to can you get me a native OPC server with some information model like a PADM or something like that, which brings more context to a data. So others talked about, having a more meaning to a data that you can bring it with the help of information model. With the information model, more context comes to the ingestion point, better data comes, and now as you get more data, now client expectation goes, okay, phase one is over, now I have reports in cloud, getting a real time view of the data. Now give me some decision making, help me do a decision making, and there comes predictive maintenance where the next set of components come in, where Azure can help it doing some data messaging and doing predictive maintenance, and that's how this project will move on. So in the next phase, they will start helping them, telling what should you do in the next 10 hours, 20 hours, a week, or a month.
Sure,
okay,
sure.
and then the whole concept becomes complete. Okay.
Got it. Yeah, I think that sort of perfectly summarized what we wanted to sort of convey and all of these points, right? So I think we have a couple of questions, Praveen, that came in, like where what are the different OPC products that were used in the OT data management side? I think this was along the lines of what you mentioned in your phase one. You said you would use the wrapper, tunneler, and all of that, right? Like what sort of thing? How did it sort of come about?
Yeah. So see, the what we did is the product we used was first we use OPC wrapper because at the customer side they already had these old classic DA servers which were running already and getting a data. Okay. Now once you put a UA wrapper just takes the data from as a DA client and converts to a UA server. So once we use OPC wrapper, it became a UA data. Okay, so that's the first product. Then UA wrapper was again used, but with a proxy together, OPC proxy. Now with the OPC proxy and wrapper, it becomes a tunneler that you see in the PPT wherever we have firewall and DA data was moving on. We also use some tunnelers there. Okay, so wrapper can do multiple loads. It can just convert to a UA and can also become a tunneler, a part of a tunneler. Okay, so UA proxy, UA wrapper came in. With the help of UA proxy, UA wrapper, we could start bringing all the data to the top layer. Okay, in this case that we are talking about, almost all the product had a classic server, so wrapper and proxy did the job. Okay, once we came to the top, we use a third product, which is the PubSub bridge, where on the south side, it can take a data as a TCP/IP client, and on the north side, convert it to the PubSub bridge. Okay?
Got it. Perfect. So I think the other question is along, I think for Adarsh, might be a little more relevant to answer this, where, so this, I think Praveen just briefly mentioned, right? So this is not like a 1 hour, 2 hour, or a few days worth of effort, but understanding these legacy systems it takes a lot of time. Is there a typical timeline that you've seen? Again, it might be an open-ended questions where like your inputs would be great for that. Where is there a typical timeline to say how long does it take to sort of set up this whole Azure cloud side of things to sort of make sure OT data is integrated?
Okay, yeah. See, quite a difficult question to answer with the typical timeline. But see, usually what we do, especially when we are commissioning services like this on the Azure, so we set up a base framework. When I say base framework, it will have an ingestion point, and there would be a data collection point, and there would be a reporting viewpoint or a visualization point.
Right.
we will divide this into 3 or 4 phases, or 3 or 4 layers: data ingestion point, data collection point, and the visualization point. And then
Right.
we start adding the services based on the use case that we want to solve. See, as you can see on the data collection point, there are Cosmos DB, Azure SQL DB, data catalog. I will not be using all 3 of them. Based on the data usage, or the based on the data use case, whether it's a structured data I want to save it, or non-structured data I would want to save it, based on that I will take either relational, non-relational. So we just
Right.
keep the 3 layers ready, or the
Mhm.
subnets and all those things, network topology and all keep ready, and
Mhm.
then we start building the services on top of it.
Right.
So precisely this might be like, as Praveen mentioned, from somewhere ranging from 3 to 6 months to prepare this data layers and all that. And once the data flow comes in, there
Mhm.
will be minor modifications on the services, because that as you start getting the data, you will start seeing more meaningful reports and visualization. There will be minor tuning of the services. Overall,
Right.
it would take somewhere 3 to 6 months or 9 months time.
Okay. Praveen, I think one more question that's come in from Asmad, where what is the value proposition of UA PubSub in this situation?
See, that's a very interesting question, right? So this debate has been going on for some time, right? What does exactly OPC? Because many people keep comparing OPC Web PubSub with MQTT, right?
Mhm.
See, OPC Web PubSub is the glue here. Okay,
Mhm.
for any kind of digitalization, OPC Web PubSub is the glue or the key here, because it's the only protocol currently in the market, okay, which can do a justice to all the OT data, get all
Mhm.
the OT data in whatever format, add the context that is required with the help of the information model, okay, and convert to cloud without any distortion. When
Mhm.
you're putting the data on the cloud, okay, see, in earlier days before all this thing, as the data moved the layer, there was distortion, right?
Mhm.
Without losing a data, without losing a data values or any context, okay, getting a data from all of them, putting to a cloud, OPC Web PubSub is the only protocol that we are aware of it.
Yeah.
Okay, and that's why there are so many bodies working on it. So I would say, for any kind of this work, OPC Web PubSub is a requirement. Without that, we can't do it.
Sure.
At least,
Sure.
that, not the. I mean, they are the best solution, basically. Yeah.
Yeah, I think just to add to that, I think we're also seeing uh, some more adoption along the rates of like MQTT Spark plug and
Hmm.
along those lines, right? So, of course, at the end of the day, information models are key. Like I think
Yeah.
that's what stands out. So whether you achieve it through PubSub or any of these
Yeah.
alternatives, it's fine. So
Exactly.
that's where at least PubSub played a big role in this
Yeah.
particular thing, right? So another question from Melvin, Praveen, where how is plant historian implemented? Is it with OPC UA? This might be a
Yeah. So
general question, not related to this, but yeah, I think
yeah.
good to address.
Yeah, so if you look at plant historian, right? I mean, so which are the plant historians? Some of those. So OSI Soft, which is Pi historian.
Hmm.
Let's take a case of OSI Soft, right? OSI Soft has started giving Pi connectors, which are OPC UA clients. Okay, so when you
Hmm.
have a Pi connector as OPC UA client, you can take a data from south side, okay, in a DA format or in a DA profile.
Hmm.
Okay, and because it has a native now UA connectivity, it can also start getting the information model using the browsing. Okay, so in the plant historian, you have in the plant historian with the help of the information. See, for example, OSI Soft, right? It also gives data modeling, which even before the cloud came, IoT Hub, Digital Twin came in, right? This
Yeah,
concept did exist in plant, but it
correct.
was not proprietary products where you create
Right.
a data model, the digital a software model of the assets and feed the data. Okay, so OSI Soft always had that, which are with the help of Pi Vision and all that. So now with the UA connectivity, you can get that all the units and their static properties, everything showing properly, and then live data was coming with the DA profile with the help of
Yeah.
UA client. So with the
Hmm.
UA connectivity, it became much easier for the plant historian to show complete data. Okay, with a one connector, which was earlier with the help of two or three connectors. Okay,
Hmm.
with the in the DA world or classic world. So actually, it is
Hmm.
much simpler now, and almost every plant historian like Take or OSI Soft implement UA client connectivity.
Okay. Uh, one more question, I think, Praveen. So, is there any additional cost linked to convert OPC DS server to US server? Most of the clients have to cover this from their perspective.
Yeah, so there are two things, when you say convert DS server to US server, right? One is to take out the DS server and put a US server. Okay. One is to put a wrapper on top of a DS server and get a US server. The second option is very easy. Okay, so that is what we did in this specific scenario in the phase one or iteration one. We put a wrapper on top of a DA server, and the DA data became a UA data. Okay, the advantage is it's very simple. There's no way the data will be corrupted, and there's no downtime and all that. Okay, that the con of this or disadvantage is that only classic data is available in DA world. In the classic world, information model was not available.
Correct.
Okay, many more data was not available. So even though data is coming in UA format, it is only the classic data converted to UA. Now the another option is you take out the DA server, have a US server, and that way you can get lot more data. That's a longer option. That's a longer option, but a better option. So we always suggest that in a phase one, iteration one, as I said, this is like a year-long or 2-year-long projects. In phase one, have a wrapper, so that when the phase one is over, a couple of things are very clear. First, on the network level, the entire network layer, right, where your networks are there, right, all the network layer OPC UA is passing now. So you know OPC UA is running smoothly on the network layer. There's no issue with that. All your ports are cleared. COM-DCOM is taken care of it. There are single port communication happening. It is much more efficient, and let it run for some time. Okay, in the phase two, iteration two, when this is stabilized, one by one, start taking out the DA and the wrapper and replace it with a native UA server. Okay, with the help of support of a vendor or you built it or whatever, where you can take extract lot more data, have information model, bring lot more context. Now the same device is giving you lot more valuable data and going up to cloud, where others were talking about having more context. Okay, so that's what we do about it.
So just to probably go from there, like for example, you mentioned about option one being you sort of use a wrapper. So wrappers can start with let's say our OPC UA wrapper starts at even like $900,000 per instance and can support up to 50,000 tags a second. And whereas when you sort of want to sort of convert it into a UA wrapper and develop a new wrapper, for example, support, the cost factor is pretty significant compared to just using a small wrapper. But there are business sort of benefits towards directly using a wrapper itself. So I think it's more of like a cost to benefit sort of thing that you would have to consider, and both have their own sort of ways to sort of address the problem. Awesome. I think we're slightly over time, guys, but I think that was well worth it considering the questions that came in, very interesting ones. So
good ones.
So I think thanks again for your time, and for coming on board and doing this. So I'm sure we'll have a lot more sessions with perspective from both ends. So again, thanks everyone else for taking time to listen to us. So I'd say stay tuned, and we'll be back with another session pretty soon. So you'll see probably another live section along the lines of an industrial automation topic from our end. So we look forward to seeing you guys, and hopefully this added some value towards your time. Yeah. Thank you.
Thank you, guys.
Thank you. Thank you, everyone. Bye.